Hello everyone, in this lecture we will discuss atomic mass, average atomic mass, molecular mass. Class 11th Chemistry CBSE, first unit, some basic concepts of chemistry. Okay friends, in this lecture we will discuss atomic mass. What is atomic mass? First of all, atomic mass, it is not a new word to you. We heard about atomic mass in class 9th. Okay, so I would like to give you points directly what is atomic mass. First one, the present system of atomic masses is based on carbon-12 as the standard and has been agreed upon in 1961. All of you know that already. We have an idea about atomic mass, that atomic mass is based on what is our reference? Carbon-12. Okay, so it was agreed upon in 1961. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of the one C12. 1 AMU atomic mass unit. What is the full form of AMU? Atomic mass unit is equal to the 1.66056 into 10 power minus 24 grams. So this value is very important. At least you have to remember 1.6. 1.6 into 10 power minus 24 grams. What is this one? This is the value of 1 AMU, atomic mass unit. Today, AMU has been replaced by U, which is known as unified mass. So now we are in chemistry, we are not using atomic mass unit. Just it has been replaced by small u, it is called unified mass. Note, when we use atomic masses of elements in calculations, we actually use average atomic masses of elements. So students, look at note here, when we use atomic masses of elements in calculations, whatever the further calculations we are going to do, generally average atomic masses of the elements is to be used in the calculations. Okay, so what is average atomic mass, we will discuss later. So it is briefly about the atomic mass. Main, what is our reference? Atomic mass is defined based on the carbon C12 accepted in 1961. 1 AMU value equal to 1.6 into 10 power minus 24 grams. AMU has been replaced by unified mass. This is the briefly about the atomic mass. So now we will see what is average atomic mass. Yeah, here one table is available, atomic masses of a few elements. This is a very important table. You have to by heart. You should memorize the atomic masses of some elements. Okay, no need to by heart all the elements, but at least you have to by heart this table. Clear? So atomic mass, what is the element? Hydrogen, atomic mass 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35.5, calcium 40. So all these are atomic masses of some elements. Okay, so at least you should by heart the atomic masses of these elements. This is a very important table. Then only you can solve some questions. Clear? So you no need to by heart the atomic masses of all the elements in the periodic table. No need. Okay, so at least hydrogen, carbon, nitrogen, oxygen, sodium, magnesium, sulfur, chlorine, calcium. So you should by heart the atomic mass values. Clear? There is no alternative. You have to by heart. Average atomic mass. So already we have discussed atomic mass. Now we are going to discuss average atomic mass. So what is the average atomic mass? Now we will see. Many naturally occurring elements exist as more than one isotope. more than one isotope. So what is isotope? Can you define isotope? Yes, we can define isotope. Isotopes are the elements having the same atomic number but different mass number. So those called isotopes. So for example, C carbon 14, carbon 13 and carbon 12. Look here. So the atomic number of carbon is 6. Here atomic number is 6. Here also carbon atomic number 6. In this case also 6. That means 6 is same. Atomic number is same. But what about the mass number? Different. 12, 13, 14. So all these are isotopes of the carbon isotopes. So simply isotope means isotopes are the elements having the same atomic number but having the different mass numbers. Okay. So average atomic mass many elements exist as more than one isotope. When we take into account the existence of these isotopes and their relative abundance percentage occurrence, the average atomic mass of that element can be computed. For example, carbon has the following three isotopes with relative abundance means availability and masses as shown against. This is the table. Now we are going to see one example. This is the carbon availability isotope C12. What is the percentage available? Abundance 98.892, atomic mass 12. C13 relative abundance means availability in the nature 1.108, availability out of 100%. Clear? This is the atomic mass of the C13, 13.00. Generally we consider 13 only. C14, 2 into 10 power minus 10 means 2 by 100. 2 by 10 power 10 you will get some answer. This is the abundance of the C14. What is the atomic mass? 14.00317 means 14. So just 12, 13 and 14. So how to calculate average atomic mass of the carbon? That is important now. So how to calculate? It is very simple. First, this is the percentage. Divide this percentage with 100. For example, 98.892 by 100 into 12. First one to get divided by 100 into 12 plus second case 1.108 by 100 you will get 0.01108 into atomic mass, again plus C14 value, divide this value with 100 and multiply with the atomic mass. So this is the procedure to calculate average atomic mass. So finally what is the answer? This is the average atomic mass of the carbon, 12.011 U unified mass. So simply generally we take 12 U or 12 unified mass. Clear? So how to calculate is very important. Once again I am repeating 98.89. You can do like this also, 98.892 into 12 by 100 plus 1.108 into 13.00335 by 100 plus 2 into 10 power minus 10 into 14.00317 by 100. Whatever you can take it. It is better to directly first divide with 100 and multiply, then add, you will get the average atomic mass. Yeah, this is the question homework for you dear students. Calculate the atomic mass average. Calculate the average atomic mass of chlorine using the following data. So already I have discussed and I have shown you one example how to calculate average atomic mass. For carbon isotopes, here chlorine 35 and Cl37 percentage is available. Divide this percentage with 100 into this one, again plus divide with 100 this 24.23, multiply this one and add this and this one, you will get the answer. Okay, next one is the homework for you. You have to calculate, you are supposed to calculate. Next question, use the data given in the following table to calculate the molar mass of the naturally occurring argon isotopes. Same model, so you can solve your own. Okay, don't copy, try to solve the questions, then only you can get the command over the subject. If you don't understand, you can contact me. It's not a problem, but try to understand. Next one, molecular mass. Next one, molecular mass. So as discussed so far, atomic mass and average atomic mass. Now we are going to discuss molecular mass. Okay, molecular mass is the sum of atomic masses of the elements present in a molecule. Very simple. So atomic mass only for one atom. Molecular mass means mass of the molecule. Molecule means molecule is a combination of the atoms. That is the difference. Molecule is a combination of atoms. Atoms combine to give a molecule. Directly I'm going to example. Just see here. CH4, methane. It is a molecule. So how to calculate molecular mass of the methane? So when we want to calculate molecular mass of the methane or CH4, how many atoms are present? Carbon and second one hydrogen. So what is the atomic mass of the carbon? 12. 12 plus, you no need to think about this one, 0, 1, 1 insignificant figures. So you can take directly 12. So carbon 12 plus how many hydrogens are present? 4. What is the atomic mass of one hydrogen? 1. So we have 4 hydrogens. So 4 into 1 equal to 4 unified mass. So carbon, 1 carbon atomic mass 12 plus 4 hydrogens, 4 into 1 4, total 12 plus 4 equal to 16 unified mass. This is the molecular mass or mass of the CH4. Very simple calculation. If you know the atomic mass, you can calculate molecular mass. Okay, just substitute the values of the atomic masses and add those values, then we will get molecular mass of a molecule. Similarly, molecular mass of the water H2O. So hydrogen 1. How many hydrogens are present? 2. 2 into 1, 2. Plus oxygen present. So what about atomic mass of the oxygen? 16. Students, most of the students you get confused here. Oxygen, most of the students they take 8. No, 8 is the atomic number. Clear? 16 is the atomic mass. Carbon also, most of the students carbon means they take directly 6. No, 6 is the atomic number. But we are calculating molecular mass. So what is the mass of the carbon? 12. Mass or atomic mass is different from the atomic number. That is very, very important. So here 2 hydrogens are present. 2 into 1, 2 plus 1 oxygen is present. 16. 2 plus 16 equal to 18 unified mass. This is the procedure how to calculate. Okay. Yeah, calculate molecular mass of glucose. Formula C6H12O6. Solution, molecular mass carbon 12. How many? 6 carbons are available. So 6 into 12, 72 plus a hydrogen molecular atomic mass 1. 12 into 1, 12 plus oxygen 16. We have 6 oxygen, so 6 into 16, 96. Total value 180 unified mass or 180. So what is the molecular mass of the glucose? 180. This is the homework for you. Calculate molecular masses of CH4, CO2, Na2, NO3, H2SO4, NaOH and H2O. Okay. So calculate molecular mass of all the compounds which have been given here and sent to my WhatsApp number. Next, formula mass. So the word is different, formula mass, but the calculation of the formula mass is same as that of the molecular mass. Okay. For example, formula mass of the sodium chloride. So sodium chloride formula NaCl. Okay, so 1 Na plus 1 Cl, 23 Na atomic mass plus chlorine 35.5 equal to 58.5 U. Formula mass of the calcium chloride, this is the homework for you. So then why we are using the formula mass? Because then we will see why we are using formula mass. Some substances such as sodium chloride and calcium chloride, especially ionic compounds, do not contain discrete molecules as their constituent units. In such compounds, positive sodium ion and negative chloride ion entities are arranged in a three-dimensional structure. Actually, NaCl, we cannot see NaCl directly. For example, if you take the water molecule exists as H2O, clear. But NaCl, sodium chloride, generally I will show you. Yeah, sodium chloride, generally we write NaCl. NaCl. But in general, it doesn't exist like this NaCl. Always it exists as Na plus and Cl minus. This is the existence of the NaCl ions. Okay. So some substances such as sodium chloride do not contain discrete molecules as their units. In such compounds, positive and negative entities are arranged in a three-dimensional structure. You don't need to worry, nothing here. Packing of Na plus, one is Na plus, Cl minus, Na plus, Cl minus alternate present. It may be noted that in sodium chloride, one Na plus ion is surrounded by 6 Cl minus ion and vice versa. One Na plus ion is surrounded by 6 Cl minus and 1 Cl minus is surrounded by 6 Na plus ions. Clear? The formula such as NaCl is used to calculate the formula mass instead of molecular mass, as in the solid state sodium chloride does not exist as a single entity. Okay, so why we are using formula mass means direct molecule sodium chloride does not exist as a single unity. Directly NaCl, it doesn't exist like this in solid state. In solid state, NaCl exists as Na plus Cl minus. This is the common existing. Okay, that's why we are using formula mass. Nothing is there. Procedure is same. Formula mass of the sodium chloride 23 plus 35.5 equal to 58.5 unified mass. Formula mass of the calcium chloride. This is the homework for you. Try to solve the problem. Okay students, thank you for watching my video. If you have any doubts, you can contact me through my WhatsApp number and email. Okay, once again, thank you so much.